This puzzle is called Knotty or Nice by XS. I got it from the Sudoku testing submissions channel of the CTC community Discord. Let's take a look at the rules. Digits in a cage must sum to the given number in the top left corner. So these 5 digits sum up to 28 because that's the digit that's shown up there. These 2 digits sum up to 4. These are sum up to 9. It's pretty straightforward constraint. Cells separated by a white dot must be consecutive. So, like these two must be consecutive. That means that they have a difference of 1. So if this is a 4, this has to be a 3 or a 5. If this is a 1, this has to be a 2. That sort of thing. Cells with white dots in their corners apply this constraint diagonally. Both constraints must be satisfied. So that means, let's go like right here. This would have to be like if this was a 1, this would have to be a 2. But then also these sides will have to be consecutive as well. And it looks like there's always a white dot there, which is going to make a whole bunch of stuff happen. So yeah, I don't know how hard this is. I think this was posted yesterday. No, this was posted 12 hours ago, overnight, for Americans at least. So I don't know how hard this is. It doesn't have a lot of solves, but of course it was posted overnight, so that could just mean no one's gotten to it yet. But yeah, I'll put a link to the puzzle down in the description if you want to give it a try, and let's get going. So the first thing I see is this 4 cage. The only way to make 4 in 2 digits is 1 and 3, since of course you can't do 2 and 2. Now, if we tried to put a 1 here, the puzzle breaks, because we have to... This white dot means that these 2 digits must be consecutive, so this must be a 2. But then this kind of corner white dot means these 2 must be consecutive, which means this would have to be a 2 as well, which obviously just doesn't work. So this must be, must be a 1 over here, and this must be a 3. Now these two both must be consecutive with 3, so this is a 2 or a 4. If we made this the 2, though, then we have this diagonal, and this has to be consecutive. So this would have to be a 1 or a 3, but it can't be a 1 or a 3. So this must be the 4, this must be the 2, this must be a 5. Okay. I guess we could look up here. This is either a 1-9 or a 3-7 because we have a 2-4 in the column, so those are the only 2 options that work. This can't be a 1, same reason as down here, because both of these would be a 2. This can't be a 3 either. If this was a 3, this digit would have to be a 2 or a 4, and of course have those placed already in the column. So we're removing some options. If this is a 9, we run into the same issues as the 1. If this was a 9, both of these would have to be 8. So that's not possible. So this is 7, this is 3. Great, okay. So this is 6 and 8. And this will act as like kind of a chain, or I guess chain is the fine word. So you can kind of see down here, it goes 2, 3, 4, 5. It doesn't skip anything, it's just like a set of consecutive digits. So the same thing happens here. But we don't know if this is the highest or the lowest. So this could be, oh no, there's a 5 there. Okay, well, I was going to say this could be 5, 6, 7, 8, or 9, 8, 7, 6. And either one of those, in a vacuum, if this wasn't a 5, both of those would work. But we have a 5 right here, so this can't be 5, so this must be 9, 7, 6. Okay, just by Sudoku, this must be a 1, because we have a 1 looking up here into the box. This is 2, 4, 5. That doesn't really do a whole lot. Okay. What's left is 6, 7, 8, 9. I'm only typing that in because this can't be 6, 9, and this can't be 7, 8. So at least we get a little bit of information there. Let's look at this 9 cage, I guess. So this can't be 1, 8. Could be 2, 7. Can't be 3, 6. Could be 4, 5. Is that what I want to do? I think so. Like, the only other option I think is this corner. And we don't have digits looking into the box. Now I'm looking at box 5 and seeing if there's something here going on that I can't quite tell. So this is connected to this, which is connected here to here to here to here to here to here to here. Oh, that is just one chain. That doesn't look like one. chain. So I think the middle digit must be 5. Then 4, 6 on one side. Then the next one will be 3 or 7. Then we kind of go across the diagonal to 2 or 8. And then the last one will be 1 or 9. So this is just going to be one kind of windy chain through this whole thing. Once we get any one digit in here, we're going to get a whole bunch of information, which is great, always. Okay. So, are there any of these digits that don't work? Oh, this can't be a 7. That's something. If this was a 7, this would have to be a 6 or an 8, and we already have 6 and 8 in the row, so this can't be a 7. So this can't be a 2. If this was a 5, does that run into problems? This can't be a 6, so this would have to be a 4. Oh, that does run into problems, because this was a 4 right here to make 9. Let me just double check that. If this is a 5, this must be a 4, because that's how you make 9 with a 5. This side must be a 4 or a 6 because it's a consecutive dot, and we have 4, 6 in the row. Yeah, okay. I wasn't expecting that to be broken, so I was I thought maybe I made a mistake or something. Okay, if this is a 4, then this is a 5, and that breaks, actually, because these two need to be consecutive with 4. One of them can be 3, but the other one has to be a 5, and this 5 breaks that. So this can't be a 4, this can't be a 5. So this is a 2, 7. I think the same thing's going to happen down here, that we can't have consecutive digits in here either. Which makes sense, because, yeah, I'll have to remember that for once I get down there. So this is a 1 or a 3. This is a 1 or a 3. This can't be a 1. If this was a 1, this would have to be a 2 again, because these two have to be consecutive. So this is a 3, 1. This is a 4. This can't be 2. This can't be 4. We know a 3 is in the middle here, but that's not that restrictive. Yeah, that's not that bad. Oh, I guess we also know there's a 4 in the middle here. But again, it's not that restrictive. If this is a 4, this is a 5. If this is a 4, oh, this can't be a 4. If this was a 4, this would have to be a 3 or a 5 because of the dot, but we have a 3 and a 5 here. So this can't be a 4. One of these is a 4. But that doesn't really tell us all that much. Okay. Maybe we look at this. Unfortunately, we have a 1 looking in, so this isn't quite as powerful. It doesn't, since 1 doesn't remove an option from summing to 11. So it could be theoretically 2, 9. It can't be 3, 8 because we have the 3 in the column. It could be 4, 7. And I think at first glance it could be 5, 6, but I don't think it could be 5 or 6. If we tried to put a 5 here, okay, well, there's a 5 there, so it can't be 5. If this was a 6, this would be a 5, and now one of these has to be a 5 as well, since we have to have both consecutive digits up here. So this can't be a 6, 5 either. I don't think this can be a 9. I think I've ran into it, I think, over here. Yeah, because these would both have to be an 8, because there's only one consecutive digit with 9. So that breaks. Oh, and there's just a 2 right here, so this can't be a 2, this can't be 9. Oh, okay, I'm surprised that worked out, but it did, so that's great. I thought we were going to have to do something a little bit more difficult. And in fact, I don't think this can be a 4. If this was a 4, we would need a 3 and a 5 along here, but we already have a 3 in the row. So this can't be a 4, this must be a 7. Which makes this 6, 8. And then this can't be a 6. If this was a 6, this would have to be a 5. And we have a 5 already in the row. So that's resolved just like that. So this must be a 9. We have a 7 forced into here. We have a 4 forced into here. What's remaining? 1, 2, 3, 5. This can't be a 2 or 5. This can't be a 1 or a 3. This can't be a 2 because of up here. I guess I didn't do this. What's left here is 5, 6, 8, 9. This can't be an 8. This can't be a 6 or a 9. One of these is a 2. I don't think that helps. Okay, so we have to find... Oh, this is actually super restricted. I didn't realize this was 16. I don't know how I didn't realize it was 16, but it is 16. There's only one way of making 16 in 5 digits. It must be 1, 2, 3, 4, 6. These can't be 4, this can't be 1 or 3, these can't be 2. Which gives us a 2 looking upwards, which unfortunately doesn't interact with this. Although this 3-7 pair does remove 3 as an option from there. And also removes 3 as an option from down there. So one of these is a 3, which puts a 1 here, which then looks back into the grid, and these can't be 1s, which puts a 1 here. Then this must be a 2. Then we have a 3, 4, 6 along here. This can't be a 7 or a 9 or the 6 that's in the box. This must be an 8. Makes this a 7. Okay. This 2 is looking over here. This can't be a 2. Whoops, so this must be a 2. Yeah, okay, so what's here? 7, 9? Which puts a 9 in the middle box up here, because we have nowhere else to put a 9 in the column. Similarly, an 8 is in here. Although it can't be in this row, I guess there's an 8 looking over. And this can't be a 9, because we have a 9 looking over. Let's see, 1, 2, 3, 4, 5, 6, 7. Yeah, only 8 or 9. 8 and 9, I should say, are pushed over here. Which doesn't really help the situation, because you kind of expect 8 and 9 to be in a large cage. Okay, what are these last two? This is an 8. Oops, this is an 8 and a 5. Yeah, that doesn't really help all that much. What about these cells? 4, 2, what's the last one? 8. And then we have a 2, 8 here, so this is a 4. So this is a 5. What does this sum up to? This is 10 plus 4 is 14. This has to add up to 7. And it can't be 2, 5. It can't be 3, 4. This must be 1, 6. We have a 1 here, so this is a 6. This is a 1. This 6 makes this a 9. This is 6. What's digit in this cell? This is a 9. Is that a 9? Just double checking that, because it's going to do something huge here. It's going to get us figured out with this line. And what's remaining here is a 3, which goes there, and a 7, which goes there. Okay, what about across here? Oh, this must be a 7, because we have 4 7s looking into the grid, or looking into the box. So what's left here is a 3, which must be here, because we have this 3, and a 9, which must be here. So this is 19. This has to sum up to 6, and it can't be 2, 4. This must be 1, 5. We have a 1 right here, so this is 1, 5. This 9 rules a 9 out of up there, and actually there's a 5 here, so these can't be 5s. And we have a 5 here. I didn't notice that. This can't be 5. So this is 8. This is 5. We have a 6, 9 pair over here. What's left is a 4, which is put down here, and an 8. Then an 8 here, 2 here, 2 here, and a 6 here. Okay, oh, this 9 is looking over. This 5 is looking over here, although that doesn't finish things. Oh, this can't be an 8 or a 9. We said 8 and 9 have to be in these 3 cells. This can't be a 9. This can't be a 9. This is the 9. Similarly, these 8s are looking in, putting an 8 here. So this is a 4 or a 6 in the column. And we have 3, 2, 5 in the row. And this can't be a 2. Oh, we have a 4 right here. This can't be a 4. Oh, we have 8 right here. And we have a 9 right here. And we have a 6 right here. Okay, that removed a decent number of options. This can't be a 5 any longer. So we need, what is it, 17, so this has to add up to 11. Oh wait, so we also have the 3. We have the 8, 9, we have a 3, so that's 20. So we need 2 digits that add up to 8, including this cell, which means it can't be a 4. It must be 6, 2. 4, 2. This is a 4, 3, 6, and that's just going to finish off the grid here. This is a 7. What do we need? We need a 1 that goes here and a 5 that goes there. Yeah, that was probably like a 1.5 out of 5. Not too tricky. A lot of just like, this was clearly the place to start. But then after that, it was just a lot of like, can this digit actually work in this, with this number of consecutive digits in each corner? And then, you know, that just kind of looped around the grid, and then then we could actually do some work here, and maybe we could have done some work here earlier that I didn't think about it, but I don't know if it would have been useful work until we got all the way around the grid. Because like we had this 2, which did force the 2 here, but what does that really mean when you don't know anything about the top of the grid? Yeah, I think we mostly did it the intended path, I think. Either that or we really messed up the ordering. Because the way that I did it seemed very smooth. Yeah, it solved very smoothly all the way around. Even when I didn't think it would, like down here. And there was actually just one option. Anyway, that was a very nice puzzle. Thank you. I'll go with don't think I can highlight the title, but I will choose nice with this. That was very fun. I enjoyed that. So thank you XS for the puzzle, and thank you all for watching.